All right, guys, welcome to another episode of CUDA Education. We're just plowing along, guys. I don't really yeah, we're just plowing along. I have been just putting on some energy into this shader groups conversation. So we'll just go along. So if you want to join, definitely tutorial number 1 to install the Vulkan SDK, tutorial number 13 to install the these examples here. If you want to be able to run the ray tracing stuff, you're going to need to make sure that you have a ray tracing capable GPU. For NVIDIA, it's RTX and above. Can't tell you about the other GPU vendors, but even if you can't run the ray tracing stuff, you should still be able to run everything else, assuming your GPU is at least Vulkan capable. So there's Vulkan capable, and then there's ray tracing capable. Okay, there's two distinct things. Just because it's Vulkan capable doesn't necessarily mean it's ray tracing capable. Anyway, so we have this shader group conversation. I don't really. I mean, the code here kind of is explicit enough to a certain degree. I just wanted to highlight that, for these 3 guys here, or 4 guys here, between the RayGen group and the MIS group, it's the exact same. Okay, so I don't know why. For the closest hit group, it's different. So the closest hit shader here, this conversation moves to this, and then the general shader is unused. I don't know exactly why that is, but that's that for this guy. Okay, we do have VK pipeline shader stage create info, so it's a vector of shader stages. So right, so these are shader groups and shader stages and all that stuff, right? So notice that the S type, so we have our ray tracing shader group here. We have the same for the MIS group, but then for the closest hit, it changes. So it's no, it's actually the same for. Sorry, it's the same for all 3. So ray tracing shader group, ray tracing shader group, ray tracing shader group. Right, the S type is the same, but the type. So for the RayGen and the MIS group, it's the same, but then for the closest hit, the type is VK ray tracing shader group type triangles hit KHR, right? And we can right, so this type is specifies a shader group that only hits triangles and must not contain an intersection shader. Only closest hit and any hit shaders. You guys could definitely Google it and put some more information into, put some more energy into what this means. But just know that for this guy, it's different. And then, we have this vector situation. So the vectors are like in a queue, and then you push them back each time. For this video, what I wanted to discuss is this SPIR-V conversation, right? And how do we generate the SPIR-V file? What is SPIR-V? So SPIR-V basically is a proprietary language by the Kronos Group. Kronos Group is what created the Vulkan. And basically the purpose of this language is to make sure that all instructions and code between, let's say, a game and a game studio and how the GPU interprets it is the same. So previously in the olden times, you had different GPU manufacturers and you had different game studios, and every GPU manufacturer might interpret instructions slightly different. Because they would interpret instructions slightly different, you had all kinds of issues with when games would launch, that for some systems it would work perfectly fine. For other systems, there would be bugs, it would crash, it wouldn't run, it would only run for a certain time. Instructions would be misinterpreted, all that good stuff. So SPIR-V is an attempt by the Kronos Group to basically ensure that whatever the game studio intended is whatever the GPU interpreted as, right? There's no, there's no miscommunication, misinterpretation. There's no equivocation between the two things, right? It's one of the reasons why back in the day, in the console gaming versus PC gaming argument, people would say console gaming is better because you basically bought the game, you put it into your console, whether it was a cartridge or a CD, and it would just run, no questions. With PC gaming, it could either run really smooth or it could be hell, because depending on your system and setup and all that stuff, things would run differently, and you would have issues, and you would have to go to either the game website or the GPU manufacturer's website and download drivers and all this and all that and do changes and change settings. And for people that are not computer gurus, it was a problem. Anyway, so that's what this SPIR-V conversation is about. All right, so in the Solution Explorer, we know that we've been messing around with the source code, Ray Tracing Basic, which is this guy here. We compile and run it, and we get our triangle, right? So this is pretty straightforward. We don't have any issues with this. This is a ray trace triangle. Okay, fine. So now we're dealing with shaders, and we have to compile these shaders. So we have a raygen, a miss, and a closest hit shader, right? And we have to compile these shaders into SPIR-V so that it could all work fine, right? So that's this is the process that we have to go through now. So in order to do this, we have to go to compileshaders.py. So compileshaders.py is a Python script. This is by Sascha Willems, but it's basically a script that allows us to take these shaders and compile it into SPIR-V, right? .spv file. Okay, so that's what this guy is. Okay, I'm not really going to go through the in-depth what this code is at the moment. I just want to run through the process and get you guys up to speed. Okay, so we have these shaders, and then we have to compile it into SPIR-V, and that's what this guy is right here. Okay, so if we go here, we could see that I've already created this SPIR-V, but basically we have our RGen thing, which is this guy here, right? Which is under shaders, GLSL, ray tracing basic, right? And we want to create this guy, which is this .spv file. Okay, so we have this and we want to create that. Okay, obviously for me, and I assume, like, I think it's already there. It's already there. Like once I concluded tutorial number 13, these SPV files are, I believe, are already there. So because I was just able to, after I installed everything, I was just able to run it and get our triangle, right? But we, obviously we're here to learn and to figure out how all of this works, right? So what you have to do is you have to do Windows key R. So you hold down the Windows key and you press R. Windows key is the 4-quadrant button on the lower left-hand side of your keyboard. It's between the Control and the Alt key on the left-hand side of the space bar. So you have your space bar button, and then you hold down Control, and then you do R, and then you type in CMD. So you'll get something like this. You type in CMD, and you will get, let me just do something. Right, so you get your command prompt, right? So then you type in Python and press enter. Now you need to make sure Python is installed on your system, because Python is what is used for that compile shader script, right? So if you press Python and press enter, it's going to attempt to install. It might take you to like a Microsoft App Store, and you're going to have to download and install it and all that stuff. Once it's installed, just reopen, do Windows key RCMD again, reopen this thing, and then you're gonna get to here, right? So you're gonna have Python on your system, right? So then once you do that, you're going to basically do Python, and then the directory to the compile shaders. So this compile shaders.py. So you're gonna have to download it onto your system, download this file, and then you're gonna do Python. So you're gonna do Python directory, and then directory to the compile shaders.py, right? So once you do this, you're gonna press enter, and then it's basically going to it's going to compile all the shaders in the in basically the whole solution. So let me just run it on my end. And then as you can see here, it's basically it's running all of the no, it's basically running all of the it's basically running all of the I don't want to show. So it's basically running all of the it's doing all of the so if we go to ray tracing basic, we see that we get our files here, right? So ray tracing basic, closest hit, miss, and raygen, right? So that's pretty much it errors out at the end, but that's all right, right? But basically, for all of these different shaders in the different applications and whatever, it's gonna compile the shaders, right? So we're interested in these guys right here, and that's what creates this right here. Okay, so we have closest hit, miss, raygen, whatever, and that's so these are all SPIR-V files. So basically, the shader has been compiled into SPIR-V, and that's what the application uses here, right? So that's this guy. Notice that also for raygen group, we have VK shader stage raygen, VK shader stage misbit, and VK shader stage closest hit, right? So that's a difference there. And then that's pretty much it. I don't really want to get into this too much. Just notice that the bindings, so we had our acceleration structure, uniform. We had our acceleration structure. We had the storage image, and then we have our uniform buffer. Notice that the bindings are consistent, 0, 1, and 2. Notice that the bindings are consistent with what we had. Binding 0, binding 1, and binding 2, right? So remember in our descriptor set conversation, we talked about how, in the descriptor set conversation, we talked about how descriptor sets are basically, it's supposed to, set up memory and describe what's going on. What are these memory objects? It's not just a blank USB stick. So you have different bindings for different things. So 0, 1, and 2. So remember, acceleration structure was binding 0. Acceleration structure binding 0. This was the storage image / result image, because they did a little switcheroo, but it's the storage image thing here. So you can see the storage image right here. That's binding 1, right? And then we have our uniform buffer binding 2, uniform buffer binding 2, right? So notice that at least we're consistent there, right? So for our regen scripts, we have all of this guy. I don't want to get into this specifically right now. I will probably in the next video elaborate more. Let's just focus on the regen shader. Obviously, if you install this solution and everything, you'll be able to do your own investigations. But that's that right there. So we have that, and then there is this is an interesting conversation. So I know this is called the regen. This is called the regen shader, and in my head I was just like, oh, it's a regen shader. It's like we're deciding how many rays are being pushed into the scene and all that stuff. It's not quite like that. It's not quite like that. It's a little bit different from what I assumed. This has a very interesting conversation, but I will save that for another video. And then we have a lot of camera operations and stuff, and then stuff here, but we'll save that, right? So now let us get back to the SPIR-V file, right? So we have our SPIR-V file. So what we need to do now, just give me a second. What we need to do is we need to go. All right, so what we need to do is basically Google SPIR-V Visualizer, okay? Google SPIR-V Visualizer. And then the SPIR-V file that we created, the SPIR-V Regen Argen SPV, right? The SPIR-V file, you're going to drop it. Once you go to SPIR-V Visualizer, you're going to drop this file into it, and you're going to, it's going to show you what the SPIR-V code is, right? I have no clue how to use the SPIR-V language, but I could look at it and act like I know what it is, right? The only thing I would say is just pay attention to this guy. So notice that in our code, we had these declarations of 0.001 and then 10,000. And then in the SPIR-V, we have 0.001 and then a whole bunch of stuff and then 10,000. So at least we know this is, something to look at. And then there's a whole bunch of other stuff. But guys, this is, I want to see, where's the bindings? Binding 0, binding 1, binding 2, descriptor set 0, right? So, I mean, in your own free time, feel free to see like what all of this is and how it matches up to what all of this is. But this is what is sort of interfaced with the GPU, right? And and you know, I guess Vulkan and all that stuff, right? But this is what is basically used. This is Kronos Group's attempt to clean up the insanity of, I ship the hottest, latest game to all my fans, whether it's whatever game is out there, right? And for a good chunk of them, it doesn't work, or there are bugs, or it crashes, or you know, it works to a point and then crashes, right? This is Kronos Group's attempt to put everyone on the same page. So you take you know, your shaders and you boil it down to SPIR-V, right? That's all I can contribute at this point. So you're looking at real life GPU stuff, and you know, have at it, guys. Definitely Google it, figure out what is what. But this guy is going to be really important. I will discuss that in another video. But here you have it, guys. So this is that's pretty much it for this video. I don't really have much else to add. Just notice that these guys, shader group, raygen, miss, and closest hit, right? And that takes us up to create the ray tracing pipeline, right? So we're up to line 670 at this point, right? And these are the shader groups. We still have a good 200 plus, 230 or so. Yeah, 240, you know, something like that. We still have a good chunk of code to get through, but we're making progress. All right, we're making progress. We just got to persevere. This is our first render pass through the code, and we're just trying to get our bearings, right? We're doing the most simplest, basic ray tracing script that we have, and we're just trying to get our feet wet in this game, right? So I'm running a GeForce. So notice that it's an RTX graphics card. So I actually have you know, a ray tracing capable Vulkan-capable GPU, right? So you guys have to figure that out for yourself. Again, guys, tutorial number 1, tutorial number 13, if you want to run this stuff. I have everything even in a series, so you can download the whole series of tutorials for doing just a basic triangle. It's not this triangle here, it's a different triangle, but that's just like for the standard issue Vulkan stuff. But I'm interested in ray tracing, and I'm taking you along for the ride. I will make sure to include the links to the compile shader below, also the SPIR-V Visualizer, and yeah, guys, we're just working our way through it. I mean, that's the best I could tell you right now. As I learn, you guys learn. Support the channel. Tell your friends, get a group of your friends together. I keep telling you, yes, you could play the video games and you could play FIFA and play whatever else you're playing, but like, spend some time learning something. Computer graphics is the future in one way or the other. So I'm taking you along for the ride. Let people know, subscribe to the channel, tell people about the channel. I'm sure if you're a hardcore gamer, you probably have one of the latest GPUs, so you could probably run Vulkan and run ray tracing. All right, guys, thank you for watching. Have a great day.